Hello my dear NSEJS students, I welcome you to NEET World. So we will be discussing the questions of NSEJS Chemistry part from 2023 paper. Okay, so here the first question is about during the formation of which are the following ionic species, the process will be exothermic and endothermic respectively. See, there are 4 options, each option includes 2 ions. So during the formation of these ions from respect to atoms, we have to identify whether it is exothermic or endothermic. Looking at the process, what process included there. So look at here, the first one here given sodium ion. So during the formation of sodium ion from sodium atom, so what is the energy involved here? What is the process it is? So generally we know atom converting into ion, cation, right? So one electron is released during the process. So what is this process? Ionization. It means from the atom one electron is removed. So what is that process? Ionization energy. The energy involved here is ionization energy. How can we define that? The amount of energy required to remove the electron from the outermost shell of this atom, this sodium atom, in its neutral gaseous isolated atom. So it should be a neutral gaseous isolated atom. From that we are removing one electron. That is what ionization energy. So I told that amount of energy required. So what is this process? It is an endothermic. Why endothermic? Because from the atom, if this is an atom, electron is there. From here we are removing electron. So pick out this electron requires some external energy right now. So we are supplying some energy from outside. So what is the process it is? It is endothermic. Okay, heat is absorbed by the system during the process. So this is endothermic. And chloride ion formation, see from chlorine atom, chloride ion is formed. So to this chlorine atom we are adding electron. So addition of electron, what is this process? Electron gain enthalpy. It means when an electron is gained by neutral gaseous isolated atom, energy is released. Generally chloride ion, chlorine converting into chloride ion. So this is electron gain enthalpy. So during this process some amount of energy is released. So I can say this is exothermic. Okay, this is exothermic. Okay, they are saying first one should be exothermic, second one should be endothermic, but this is in reverse manner, so it is incorrect. So if you look at the second option, so chloride ion formation, what I told you, so this is ionization, like this is what? Electron affinity or electron gain enthalpy, here it is negative. Okay, exothermic process. So for chloride ion formation it is exothermic, that is correct. So formation of O2 minus. Okay, so this can be achieved from O minus. See, first of all, you know, oxygen atom gains one electron and becomes O minus 1. So this is first electron gain enthalpy and this is second electron gain enthalpy. So always remember, addition of electron to anion will be always, there will be what? Repulsive interactions between this negative charge, this electron density and this electron. Like charges repulse, right? So between this negative charge, this negative charge, repulsions are there. Therefore, the addition of the second electron to anion species is highly difficult. Therefore, we need to force it from external. So it means we need to give some energy, we need to supply some energy. So what is this process? Addition of electron here for this anion requires energy should be added from outside. So I can say this is endothermic. Okay, so the conversion of O minus to O minus 2 will be what? O minus 1 to O minus 2 is endothermic process. So first one is exo, second one is endo. So option number 2 will be your perfect answer. You can look at here. So formation of helium ion from helium atom is endothermic, but first process has to be exothermic. So this is incorrect, remove this. And fluoride ion formation exothermic, as well as chloride ion formation from respect to fluorine and chlorine atoms is what? Both are exothermic, but one should be exothermic, another one should be endothermic as per the question. So this is also incorrect one. So appropriate answer for this will be option number 2. Hope this is clear, right? Okay, let us move further with one more question. The total number of lone pair electrons in I3 ion. So now look at here, I3 ion is there now. So what is the central atom here? So I can write this, iodine is the central atom. So surrounding atoms are also iodines only, like this. So one iodine is central atom, remaining two are surrounding atoms. Total charge is minus, right now. So now just consider central atom iodine. So iodine belongs to which group element? 17th group na, halogen family. So write 7 valence electrons, 1, 2, 3, 4, 5, 6, 7 valence electrons are there. Along with that one negative charge. So one extra electron is also added to this. So I am adding that electron also. So I have written 8 electrons like this, okay. So now how many surrounding atoms? 2, right. So each iodine is a monovalent, it can form one bond right now. So this surrounding atom, so one bond here, one iodine, and this is second bond, okay. So how many sigma bonds we got? So 2 sigma bonds. Remaining, this is a pair of electron, this is one more pair, and this is third pair. So totally what we have? 2 sigma bonds and 3 lone pair electrons. Right now on central iodine atom, so 3 sigma bonds, 3 lone pairs. So total hybridization is how much? So each pair of electrons can be accommodated in one orbital. So total how many hybrid orbitals are there? 2 plus 3, 5. So 5 hybrid orbitals are there. So what are those? sp3d. So this is the hybridization of this central iodine in I3 minus. You have to remember it like this, okay. Purely concept with a trick here, okay. So now if it is sp3d hybridization, you are going to get a geometry of trigonal bipyramidal. So what is the geometry? Trigonal bipyramidal. So it means these 5 hybrid orbitals you need to arrange around the iodine, central iodine like this. So 1, 2, 3 and 4, 5 like this. So these are the 5 hybrid orbitals. So now we know there is 2 sigma bonds and remaining 3 are lone pairs, okay. So always remember these positions which are in trigonal planar. So this red color I am indicating here. So what is this? This is a trigonal planar, okay. So what is the angle between the 2 bonds here in trigonal planar? 120, whereas with this above bond it will be 90. So this yellow color above and below bonds are axial bonds. They have angle of 90 degrees. Red color here are at 120 degrees to each other. Always remember lone pair will suffers or lone pairs exhibits more repulsion. Between the lone pairs repulsions will be more. Therefore we need to place these lone pairs with maximum separation. So maximum separation will be at 120 degrees now. So always place these lone pairs at the equatorial positions first. So this equatorial position occupied one lone pair, and this is by second lone pair, and here one more lone pair should be placed in the this equatorial position, and remaining 2 axial positions are occupied by atoms. So one iodine here and second iodine is here. So how the structure is looking? So central atom is here, iodine, another side iodine is above and another one is below here, okay. So here one set of lone pair and second set and third set. So how the structure is looking? Like a line now. So if this is the central atom, here one atom, here one atom. So like a line. So you should say it as a linear shape. What is the structure or shape? Linear. So how many lone pairs on the central? Lone pair electrons in iodine I3 minus they are asking. See, if they ask on central atom, you should say 1, 2, 3 as your answer. They are asking in I3 minus, in total molecule they are asking. So you should be conscious whether they are asking for central atom or the surrounding atoms also, or includes everything. So here they are asking includes everything. So in this case what you need to do? So you need to check for other iodines also. See, surrounding iodines are also having 7 valency electrons now, but one of the electron is utilized for bond formation. Remaining 6 electrons are there. 6 means there is each pair on this iodine, each iodine atom having a pair like 6 electrons. So each pair like that will get 3 pairs, okay. Here also 1, 2, 3. So that how many electrons are there? How many lone pairs? So 1, 2, 3 pairs. Here also 3 pairs. Total 6 plus 3. So total 9 lone pairs are there. So what they are asking? Lone pair. Okay. So lone pairs are how many? 9. So your answer should be option number D as your perfect answer for this question. Hope this is clear. If they mention only on central atom, your answer should be 3 lone pairs. Okay. So be conscious what they are asking in the question. Okay. Next, let us move forward with one more question here. Yeah, look at here, an esterification process has been represented by the following chemical reaction. The fate of labeled oxygen atom in the product is. So where this like labeled oxygen atom will goes during the reaction. So what is the estimated product from this? So we need to identify. Very easy but very conceptual. Look at here. Always remember, this reaction is called esterification reaction. I will tell you some extra points also regarding this along with the answer. See, during the esterification, we will be using carboxylic acids and an alcohol in acidic medium. Okay, so every step involved in this reaction is a reversible. So whatever the rate of forward reaction is there, so rate of backward is also same. So we can say that as a microscopic reversibility rule. Okay, so now what I am saying, forward reaction rate and backward reaction rate are equal. Okay, so in acidic esterification of carboxylic acid using alcohol. So now what happens in the mechanism? Look at here. So take that given carboxylic acid pH, C double bond O, OH. Like this they given, this is mentioned as 18. Isotope they mentioned just to look at your mechanistic way how you are writing. Okay, so that you got one H plus ion first. So this H plus ion is taken by the lone pair electrons of this carbonyl group oxygen. So it will accept this H plus ion and you are going to get something like this. O, H, O18, H, and this oxygen will be having a positive charge, right? So now due to the electronegative atom with positive charge, we know it will be having more electron withdrawing nature because of more electronegativity. Again with positive charge makes it more electron withdrawing nature, therefore it will drag the pi electrons towards itself and creates a partial positive charge on this carbon, right now, that is more electrophilic center. This carbon is now more electrophilic center now. Therefore what happens in the next step is, whatever the alcohol given here, methanol is given now, so that will attack as a nucleophile using the lone pair electrons present on the oxygen atom of alcohol here. So this will act as a lone pair, attacks over the carbonyl group. So what we are going to get, so what I told you, every step is a reversible step like this. Remember this step. Okay, so now what I can get, pH, O, H here, and this will be O18H, and here O. I will tell the trick also, just listen to the mechanism for some time. Okay, it will be like this, CH3. Okay, now this oxygen will be having positive charge, right now? Yeah, so oxygen with positive charge is unstable. So what it will do is, it will releases that H plus ion from this methanol. So that will be taken by this lone pair electrons of this oxygen here. The OH group oxygen is there now, that will be taking this proton. Okay, lone pair is taken by the oxygen itself. So that we are going to get pH, OH,
benefit.
one hydrogen here, another hydrogen here. So it is becoming positive charge now, oxygen. So that we are going to get OCH3. Okay, next what is the next step? See here, the first proton is, like first oxygen is protonated now, so that will again gives back the proton, removes back the proton, deprotonation takes place, and at the same time this water molecule will be goes out, so that we will get a ester as a product. So pH, O and OCH3. Now what came out here? So we got water, that is isotopic labeled, that one O18 came out as a water here, H2O. So this will be the byproduct here. Okay, so just remember the OH group from the trick is here. What is the trick? Always remember OH group of carboxylic acid and H plus from this alcohol will comes out as a water molecule outside. Remaining part will be forms ester, like this we have now. So OH from water, H plus from OH from carboxylic acid and H plus from methanol you take out and write the remaining product like pH, CO, OCH. This will be the product, and byproduct will be OH from water or carboxylic acid and H plus from methanol, like this. So water is liberated out. So what is your product here? So the fate of labeled oxygen O18 atom will be in the product of water. So D will be here. So D is H2O18. That will be your answer. Hope this is clear with every step. Every step is clear now? Yes. All steps, remember, all step you need to mention, represent like this, because it is a reversible reaction, which I can say it as a microscopic reversible rule is satisfied followed by this particular esterification reaction. Remember that. Okay. Next here we have one more. The bond which will break first in the first step when the following reaction when the following compound react with H3O plus. Just now, just in the back, like previous question only I have discussed. See, there is a question from esterification in 2024 NSEJS paper and 2023 also. The previous question is in 2024, asked in 2024, and this question is in 2023. Okay, so this is a concept that is must be focused. Okay, so do not skip this. So what is a mechanism? See, they are focusing on mechanism, how you are going to give the mechanism, how you are going to propose a mechanism for this kind of reaction. See, now where you need to add this H plus ion when you add when you are doing this reaction in water aqueous medium. So they will mention it like this, or they will mention H3O plus, both are same only. Okay, always remember this lone pairs will take this proton first, therefore you are going to get CH3, C double bond O, H oxygen with positive charge and OH like this. So now this oxygen having partial positive charge, why it is? I just now told you, oxygen electronegative element with more positive charge becomes more electronegative, therefore it will drag the pi electrons towards itself. Okay, so which bond is breaking now? The bond which breaks in the first step is what? This bond highlighted here labeled as B. So this B bond is breaking first. So what is your answer for this question? Bond B is breaking first. So your answer should be option number B. Hope this is also clear right now. Yes, if it is clear, just click on the like button and also share with your friends. Okay, now here one last question I have for you. So look at here. Arrange the following compounds in the increasing order of Lewis basic strength. So which is more basic in nature out of the given three options? See, look at here, the lone pair electrons here are free here, free to accept the proton. Right now basic nature means what? They should accept a proton. Okay, either they should release the OH minus ion or they should accept a proton. Then I can say that particular compound is having more basic nature right now. So now these lone pair electrons can accept this H plus ion freely. Okay, and here also we have lone pairs, this can also show basic nature. Here also we have lone pair that can also be basic nature maybe by accepting a proton. But out of these three, which is more basic? See, this lone pair electrons, nitrogen is attached to sp3 hybridized carbon, but whereas this nitrogen lone pair, this nitrogen is attached to sp2 hybridized carbon and these attached to sp2. Okay, and one more thing is the lone pair electrons here not freely sitting, they are involving in the ring conjugation like this. So aromatic nature we are studying now. So these electrons are participating in the conjugation with the ring pi electrons. They won't be donating easily, they won't accept the H plus ion easily because they are already in the game of resonance. But here these electrons are free to accept proton. So I can say one is more basic, right? After this, out of these two, how can we decide? See, sp3 means less electronegative, so this will be just present on the nitrogen atom, that will not be strongly holded on this sp3 carbon as we seen in sp2 right now, because it is more electronegative, less electronegative. So it will freely accept the proton, so it has more basic nature. After this, in these two, how can you say? These are involving the conjugation, but these are freely here, but with sp2 carbon. So relatively less basic than this and more basic than this. Okay, so this can accept the proton like this. So I can say 1, 2 and least basic is 3. So what they are asking? Correct option containing increasing order. So least is 3, least is 3, least is 3 and next is 2 and more is for 1. So option number A will be perfect answer for this particular question. Hope this is also clear. So thank you for watching. Stay connected with this NEET World channel. You are going to get very nice quality content for your Olympiad preparation for NSEJS and even for NSEC, NSEP, okay, from all other subjects also. Yeah, so if you are thinking to join with us, just contact us through the contact number or the whatever the details provided in the description box. Thank you for watching. Stay connected with us. Thank you.